I would like to start with introductions. So I'm sure there are many people who haven't seen me in these webinars lately. So my name is Marius Navickas, and I'm operational marketing, head of operational marketing division here at Teltonika Networks. I'm extremely thrilled to support my brilliant team in not only hosting these webinars, but doing all of the marketing activities together. It's a very, creative and very happily challenging position, I would say. And I've been with the company for about 5 years, and I saw it transform into something very exciting. So hopefully I will have opportunities to join these webinars a bit more often. And today I have two of my colleagues who are going to bring in fresh and different perspective into this topic as well. So let's begin with Evelina. She's our project executive, and very interested into this technological topic.
So hello everyone, it's very nice to be here and to present this very interesting topic for me too. I will just wish you to have a great time with us, enjoy, learn, and of course feel free to ask the questions. We are always open to answer them.
Brilliant. And as well, we have a bit more technical flavor in the person of Mr. Tomas Mykolaitis, who in fact is our remote management system product owner. But since Thomas is a very helpful guy, he was eager to jump in and just share a bit more technical details around the topic, because benefits use cases is something that's a bit easier to understand, but there's always a technical layer behind all of this. And I think that what Thomas has to share is going to bring a bit different light on some common misconceptions about some of the categories of LTE.
Yeah, thank you, Marius. Hello, everyone. It's always great to get back to roots where I started Teltonika. And it's to remind that I'm a more technical guy than the manager, but everything goes in different ways. So I really hope that the whole webinar for you will be really beneficial and you will take something from here. And as I really mentioned, feel free to ask any questions of us, and we'll do everything to answer those in Q&A session.
Brilliant. Thank you, Thomas. So why LTE, right? And in the times during which most of our competitors talk exclusively about 5G, we present you with an in-depth review of different flavors of LTE, also known as 4G, obviously. So we do this certainly not because we live in the past. We do this because, being one of the top 3 global providers of industrial cellular routers and gateways, we have some insights, and these insights show a tremendous and growing demand for LTE devices in the industrial and professional IoT market segments. But what I say is quite contrary to what you hear in trade shows or expos, social media, online materials, and that's what we call a marketing buzz. LTE has been with us since 2009, and it's hard to keep a topic hot for more than 12 years, but 5G is new, and it promises things like autonomous driving, remote precision surgeries from different parts of the planet. It promises the next big generational shift in the way we interact with technology. However, from the IoT and industrial IoT business standpoint, currently, there are way more opportunities with good old LTE-enabled devices. And let's talk a little bit about why. The first barrier for massive adoption of 5G is simply coverage. And it is costly to deploy it as wide as LTE is right now, and it will get there, but in time. Similarly, like with 4G, it started to spread in city centers, and spreads to the suburbs, the outskirts of the cities, motorways, and later seeks to cover majority of our habitable world. Then we have costs, obviously, due to lack of demand for 5G modules. Costs are still on the high side, and actually not by a few or a dozen percent, but few times, depending on the technology, which translates into much higher equipment costs. And most of the use cases supported by our devices don't require gigabit speeds. In fact, according to Ericsson, in 2027, so-called massive IoT will amount to 40% of all cellular IoT connections, meaning that those use cases will be based on Cat M1 and NB-IoT, which we're going to talk in a little bit more depth later during the webinar. Finally, LTE is extremely flexible technology, and looking at the global picture, the spread of 5G will be uneven as with previous generations of cellular connectivity. But it's all in the title, long-term evolution. And I believe that 5G and LTE will happily coexist. And LTE's role in our connected world can continue for maybe even more years than it has already. So let's take a quick look at what we will going to cover next during this webinar. We will get to know different LTE categories. We'll get to know their features, benefits, and applications, and of course, illustrate them with use cases to show the best possible connectivity option for you. Let's get going, and I will ask Evelina to jump in.
Hello, everyone. I'm just sharing my screen. Please tell me if you can see it all right. Perfectly. Okay, so let's start with mobile categories. And for many 4G users, LTE simply means that the phone is connected to the carrier's 4G LTE network. However, mobile categories are much more than that. There are around 20 different LTE categories that have been created and are still developed. And in industrial environments such as enterprise, automation, transportation, government, or maritime industries, those categories are defined as CATs. Not literally exactly. I mean, Cat M1, NB-IoT, Cat 4, Cat 6, Cat 12, even Cat 18, and so on. And what is interesting here, that these categories weren't developed one by one. Of course, Cat 1 was firstly introduced with a 4G in the late 2018, then Cat 4 followed, while Cat M1 and narrowband IoT were launched only after Cat 6 in late 2016 to cover the sunset of 2G. And this happened because of the need to respond and to support and serve the huge amount of potential customers that had been looking for a new way to connect their already existing solutions. But the question here, why so many, still applies. Because seeing a wide list of LTE categories doesn't make the decision of what device to choose easier. But the answer here is pretty simple. Those categories are to meet each connectivity need. Also, different categories has different variables such as coverage, network occupancy, power consumption, or hardware complexity. So choosing devices should not be something with a closed eyes, because it is all about the efficiency to deploy the best performance at the reasonable cost in your specific scenario. Another way to simply explain lte-a categories is very easy one. The higher the category, the higher speed. But it doesn't mean that you just need the highest category with the highest speeds to connect your IoT solution. The rule, the higher the better, is not absolute if we are talking about the cats. Basically, the variety of lte categories allows you to find the right bandwidth device to make your solution cost efficiently and reliable. Also, going up category by category, it's not about just increasing the speed. It also means that devices are getting more power hungry and expensive. And the reason for that is very simple one. More complex modules are used to create the higher CAD devices. For example, the lowest category modules could cost around like few euros, while CAD 12 or CAD IT 18 devices cost several times more than lower category modules. So the prime cost of the manufacturing issues, the modules, has an unquestionable impact on device selling price. So navigating around and choosing the best device based on your specific need will help you to fulfill your need and, of course, avoid overpaying. That is very important. And here I have some numbers. 5%, 35%, 60%, and you're probably wondering what these numbers means. It's not hard to guess that it's somehow related with the market share, but I hope you to surprise what they actually means. Could you imagine that high-speed connections, or in other words, the highest lte categories, take only around 5% of the market, which makes them niche? Also, 35% are the medium speed connections, for example, with the Cat 6 category or even Cat 4 category, while the biggest market share, 60%, is for the low speed connections, which proves that lte categories are in a huge need to serve general machine-to-machine communication, data gathering, monitoring, or maintenance processes. And what I'm trying to say here, that there is no reasonable argument to pay a way more for high throughput devices if you are planning just to use the fraction of its performance. Because, for example, Cat M1 then will not serve you the best performance as a public hotspot. And since I started to go a little bit deeper to features, specification, and everything else, I'm giving my word to Thomas. He will help you to meet each lte category with a more technical background and spices of that.
Thank you, Evelina. So the first category of LTE or categories which you want to present is, of course, Cat M1 and narrowband IoT, which either of those was designed for industries when lower power wide area connectivity is needed. The motivation for this category's introduction comes from expectation that growth of low powered IoT devices and the sheer number of them will only go up when time goes on. And of course, when we're having more and more devices, we are just bringing more demand from base stations and ISPs. And of course, these categories also tend to reduce stress on those on that hardware of ISP by allowing to fit more IoT devices to single cell by reducing the required bandwidth for communication. Of course, on the same side, that allows constructors to reduce the complexity and make the radio part, the radio hardware is way more simple. But on the other side, the Cat M1 and NB-IoT, as Evelina mentioned, has its downsides. It's capped to lower speeds for internet communication, and we can have here only 1 megabit per second up and down with Cat-M1, and with NB-IoT up to 26 kilobits per second. Of course, it brings other benefits these categories really brings, and those benefits are, since these categories are really new, they were developed in a way to address different problems than LTE was developed at the beginning. And of course, Cat-M1 offers fast enough bandwidth to serve as a replacement for many applications where 2G and 3G are used at the moment. And of course, we all know that it's coming to an end. Using Cat-M1 and narrowband IoT allows to enable low power devices and increase their battery life. Since this kind of modems and this kind of with these categories allows devices to sleep for longer periods of time. Since this CAT uses, of course, licensed spectrum, it ensures that modems does not have to fight for airtime, and again, ensure the efficient and better connectivity for the solution of yours. And of course, it goes beyond and beyond, but this kind of category is designed for the way to serve scenarios where poor connectivity might be a situation, and in the buildings or somewhere underground, where it can also work due to its design of reduced bandwidth and other parts. If you compare Cat-M1 and narrowband IoT, which category you should choose for your solution, the main difference between these two are like Cat-M1 is better with moving objects since it's designed more like traditional LT solution, and NB-IoT is designed for stationary objects where you have small data which just need periodically be sent to the server for data collection. So main solution for those are these two. And Evelina will help you with applications.
Yeah, so I'm jumping here to present the actual applications where Cat-M1 and NB-IoT devices unlock their full potential. And as Thomas mentioned, those categories are used in scenarios where the main goal is to get a small amount of data from one point to another with as less power as possible. And a great example of that is city lighting. It just needs to switch on or switch off the lights on specific time, and the other time device is just sleeping. Also smoke detectors, HVAC control, parking control, and many other monitoring or just sending a little bit of data applications are perfect for Cat-M1 categories. And here I also would like to add one interesting thing, that Cat-M1 is designed to not use that much network operator space. So for Cat-M1 devices, you are more likely to get the best price offer from your network operator. And let's move on to the use cases and examples. So here we are seeing a huge manufacturing facility with many industrial devices, PLC, HMI, sensors, RFID readers, panic alert button. So the goal here would be just to send monitoring data to the platform or database or server. What we need here, we need a device to incorporate everything into one network and to send that data. So we choose our Cat-M1 gateway TRB255, and it is a great choice here for the following reasons. It is a backward compatible with 2G, so it can connect different legacy devices. It has multiple interface ports, serial interfaces, inputs and outputs ports for different connectivity reasons. So PLC can be connected to RS2 RS32, HMI to RS45, and so on. So connecting everything into one network, sending the data. And please note that in this specific case, we can do a lot more, but Cat-M1 device would be enough just to collect and send that data. Remote control, precise real-time data, or for example, HMI video streaming would not be the best option with the Cat-M1 devices. And here we are going follow to Cat-1.
Yeah, so for example, looking for solutions with possibility of real-time support, HMI screen monitoring, we should look into maybe let's say higher categories of LTE, and this option would be at the beginning Cat-1. Cat-1 can be presented as low or initial version of 4G LTE. At the beginning, it was designed for IoT devices where now M1 took place for displays, and with the idea for low and medium bandwidth needs, since it has the speed capabilities required for such solutions. With still relatively simple hardware compared, with higher categories of LTE, it's a very good value device and very good value solution for IoT devices, since Cat-1 offers fast internet connectivity in comparison with Cat-M1 or narrowband IoT option, thus potentially giving the benefits of those solutions. In short, it opens new communication paths to execute way more easy commands, and of course get way more control of your solution. And of course, the benefits of Cat-1, it's quite obvious, since first of all, Cat-1 was the initial LTE standard which was first released into the wild, and it ensured, and at the moment we have, I think, the best coverage of whole LTE is a Cat-1, since its wide adoption over the globe, and of course usage by different IoT solutions. And while Cat-M1 and narrowband IoT networks are still developing over the world, and of course catching up, Cat-1, number of integrators now are using the Cat-1 category for their solutions, since again it provides the required connectivity and ensures that low power usage with the low costs as well. Of course, lastly, since this category, as I mentioned at the beginning, is so simple and so widely adopted, it's one of the best cost-effective options for any simple IoT use case where you just have to connect single or few devices to network and get that real-time control. So if you have simple solution, I think the Cat-1 is quite a good option for you.
So again, I'm moving on to talk a little bit more about Cat-1 applications that includes alarms, control panels, ATM, POS devices, vending machines, and of course enabling machine-to-machine communication. So with the Cat-1 devices, as Thomas mentioned, applications are enabled to perform simple tasks such as remote door opening, alarm, validation of credit card information on ATM or POS terminal. So in short, it opens communication and execution of easy commands between many popular market applications that we use in our daily routine. So regarding the use case, we know that nowadays remote control is possible for almost everything. And at a first glance, water pump automation case looks very pretty simple here. But it's a very good illustrating example for today. What we see in this case, we see an automation system for remote control of underground well pump in the remote monastery. In this case, the monastery was about 1.5 kilometers away from the water source. So cellular connectivity was chosen because of that remote area from well and the monastery. And what was done here is pretty simple. We connected our Cat1 gateway, TRB141, to a water pump. And when the storage tank is just empty, the people that are in the monastery can initiate and activate the filling process just by SMS message or simply by the call. And then TRB 141 just sends a signal to the water pump, and the storage tank is starting to fill. So why this device is a perfect choice for this use case is because of the various inputs and outputs options. Also, TRB would serve in another applications where devices must be remotely managed using inputs, outputs, and to perform very simple tasks such as filling that storage tank. And to conclude here about this use case, I would say about Cat1, very simple thing. Cat1 is the best category to connect one specific thing to the internet and allow him to perform his specific task. That would be the most you need to know about this category. So let's move on, I think.
Sure. Of course, going further, we go into more advanced solutions, and here we reach the Cat4. On the paper, the Cat4 was introduced together with Cat1 category. For these reasons, these two can work interchangeably, and really, it's really likely that if in the area Cat1 is supported, you can also get the Cat4 support in the same place. This is because how those categories were developed and how was introduced into market. What Cat4 makes more beneficial than Cat4, let's say better, is the ability to support 2x2 MIMO technology, what gave lte-Cat4 better communication performance and allowed to reach those 150 megabits per second speeds for downloading and 50 megabits per second for upload use cases. Of course, in theoretical design of this technology. Of course, what are the benefits of Cat4? And same as with Cat1, Cat4 has the same wide network coverage and can provide the better performance when required. With more than 10 times performance improvements compared with Cat1, it is a really safe option for the IoT solution which might or really need higher throughput for demanding high throughput demand for your M2M use case, or even maybe connecting some people to internet. And Cat4 really brings excellent value for the performance. And for this reason, it is still one of the main LTE categories used in the world.
Okay, so as Thomas mentioned, Cat4 is the most popular category, but again, it's also wrapped in some myths. For example, that is not fast enough in our today's world. However, it can easily reach 50, 80, or even 90 megabits per second download speeds. So it's absolutely enough to support full mobility and fluent data streaming. So Cat4 devices are most common in many public sector projects because it simply offers the best balance between the price and efficiency. So public transport Wi-Fi, digital signage, video surveillance, and other application that we can see in public spaces probably is connected with the Cat4 devices. And of course, it served the most common other cases, such as EV charging station, plus adding Wi-Fi hotspot to browse when you are charging your car. So we can add self-service checkout, POS, and of course, self-service parcel terminals. And as I mentioned them, I would like to take them as the example today because it's a perfect way where the Cat4 device can be used. And there is no doubt that these terminals are the complex machines. First of all, it has screens for humans to interact and process their payments. It should be clever enough to open the right doors. It needs video surveillance cameras, and it should be accessible 24/7. So bringing all these tasks together, Cat4 can bring outstanding results. In this use case, we took our Route 950 cellular router, which served as a main and backup source. It was connected to the main parcel service terminal computer. So all of these cameras, POS terminals, remote management was done perfectly without any interruptions. And again, very interesting add-on this use case would be our router can serve also as a public hotspot here. So when the guy comes to fix the self-service parcel machine and it's raining outside, for example, he can do it from the car, so he don't need to get out, and that's Cat4 is more than enough to fulfill these needs. So as the self-service machine case is a very universal one, the Cat4 is the same. It is the safe choice in those projects where you are unsure what to choose. And mainly to conclude about this category, Cat4 device will get you the balance between performance, coverage, and the cost. So moving on.
Yeah, and moving on, what technology brings us? And it brings us the Cat6, the lte-Cat6. And with this category in the introduction, LTE as technology received quite a lot of new features, which laid some foundation for upcoming categories in the future and for their growth and providing way better connectivity. And those new features were carrier aggregation, scalable bandwidth, advanced MIMO solutions, and of course, many more parts which I don't want to start talking about since it's really complex things. And of course, with these advantages which we have now, we were able to push mobile communications to the next level and achieve, for example, for Cat6, 300 megabits per second for downloading. So again, for example, some people not even have wired speeds at home, and here we're receiving with mobile. And of course, at first, let me a bit go beyond and talk about carrier aggregation and of course what the carrier aggregation is. So the carrier aggregation is a technique which allows to combine multiple frequency bands to offer more wider bandwidth for the user, which in the end results in a faster data speeds. The carrier aggregation, as I just mentioned, started with Cat6, and it extends to all other categories which you will get familiar in the future. And of course, the benefits of the carrier aggregation that device with this technology support allows to have better mobile internet speed than device speed and coverage experience, since it's not only about the speed. But of course, it's worth to mention for you that carrier aggregation only works in areas where ISP supports this technology. So it must support the towers of the LTE must support carrier aggregation, and the bands must be in the place. So don't get confused when you have carrier aggregation enabled device, but it does not combine several frequencies into one stream. And with Cat6, we get the benefits of the Cat6. And the Cat6 was the first category which consider and as a part of LTE advanced era. With it, user has received better internet connectivity speeds, way more stable internet connectivity in crowded areas or in poor signal situations. Since it has the additional bandwidth, now we can support not only a high number of IoT devices in one place, but we also can provide same internet connectivity for people who are consuming media over their smart devices. And of course, this category brought new level of performance in mobile industry.
Okay, so as Thomas mentioned, LTE Cat6 is the first LTE advanced category that comes with a carrier aggregation, what just basically doubles the internet speed. And what doors does it open to the new IoT applications? Of course, it is naturally dedicated to data-hungry applications like sharing high-resolution video streaming, making a group calls, public hotspots, because the lag is reduced. It's also a good way to have a small office backup or be deployed in another places where it's crowded and where it's remote places. And moving on to the use case, I would like to show you the smart bus use case, because it amazingly illustrates what Cat6 do here. So we have many tasks like ticket vending machine, real-time traffic updates with a timetable, digital signage, live CCTV cameras working together. And to be honest, I think that it looks like that Cat4 device would be enough here, but let's add a public Wi-Fi here and put this bus stop somewhere a little bit away from the city center. Now we have a complex scenario where Teltonika Networks Cat6 Rootix11 router would solve the issue. Rootix11 at this case can provide fast and stable wireless internet connection for up to 150 users, I think, at once, which is more than enough for bus stop use case. Also, router has dual SIM technology with an automatic failover. So if one internet provider networks gets interrupted, you can switch to another one easily. And once again, Cat6 devices perfectly provide heavy-duty connectivity in remote and crowded application scenarios. So choose if you see your solution in this way. And we are moving on to Cat12, and I'm giving my word again to Thomas. He will tell you more about it.
Yeah, so Cat12 and how we can imagine Cat12. I think the best words would describe Cat12 would be Cat6 on steroids, since this category just continue what was done with Cat6. It increased mobile performance even higher and got even better. It started to use 3 separate carrier aggregation techniques. So again, instead of 2 like Cat6, we have 3 here. Uses 4x4 MIMO technology for better communications, and even goes with higher modulation signals to go to take and carry the information required for such performance. And of course, these advancements open new window for additional performance, by doubling the Cat6 speeds up to 600 megabits per second for downloading and up to 150 megabits per second for uploading. Now we are coming into territory where mobile devices gives you such network capacity per single device and allowing to simplify solution than ever before. But of course, at such level of performance, it comes with a cost, and the cost is of increased complexity or the price of device, and of course, high power usage.
Okay, so we are having Cat12 applications, and currently Cat12 category is the highest among Teltonika Networks products. No space for any interruptions, a high bandwidth, so it can serve all the things mentioned before with the another Cat categories and much more. With a huge data output, this category is used in those places where, of course, ultra speed is crucial. So those for sure are 4K streaming, full backup possibilities, first responders with police, medicopters, and so on, and marine applications, because those are very complex ones. And for the use cases to illustrate what Cat12 does, I would like to show you something from Lithuania, from here. And we have a case where Civil Center of Education created an interactive mobile exhibition that was traveling around the Lithuania, including small remote towns with poor internet coverage. And the main challenge in this scenario was to connect exhibition fleet in different rooms and floors with over, I think, 50 different tablets and active users at once. So we needed to provide them with stable internet connection for QR scanning to learn more about what's in that exhibition. You will ask me here again, why speed is so crucial in the exhibition case? One of the hidden reasons is educational aspect. Younger generation is just basically very into those interactive things, and it keeps help to keep them engaged. So if it doesn't work perfectly, the engagement is getting down. And another one reason, there is no right reason to make interactive exhibition if it just doesn't work well. So to eliminate losing connection risk and ensure seamless learning experience with zero latency in remote areas, our fastest router Rootix14 did a great job here. So what we done, we added 2 Rootix14s in different parts of the exhibition, but thanks to its functionality, people don't need it to reconnect if they move to another floor or room. Be dual SIM functionality, auto failover, load balancing also guaranteed that when pupils are walking around and learning, they will not lose connectivity at any point. So to conclude Cat-12, I would say it's for the neediest ones who seek the higher opportunities and at the same time are open to pay a little more than for most common Cat4 and Cat6 devices. And I prepared like some beautiful wrap up of what was said, and we are having a summary of mobile categories here and that are available in Teltonika Networks portfolio. And first of all, I would say, please remember that the speeds you are seeing in this table are just theoretical ones, but on the other hand, possible ones. They really depend on many external factors like provider, location, your cable, network occupancy, and much more. So coming back to our portfolio, you can see that we well distributed it across different lte-a categories, from simple modems and gateways for Cat-M1 or Cat1 applications to ultra-fast routers for large amount of data sharing. And as you probably learned today, finding the right solution for your application should be based on several factors: your location where you plan to deploy your solution, the scale of your deployments, the data needs, and the reasonable cost of your devices for additional functionality also, like is the device has inputs, outputs, serial interfaces, ports, and so on. And for this reason, we have a broad portfolio with many features and interfaces in our devices. So you can always simply compare them on our website by using comparing tool or by contacting our sales team. But of course, today you have an excellent chance to ask us to find the right solution for your IoT device. So I think we are ready to move on to Q&A session. I hope we have questions already, so let's move.
We do. I was monitoring this situation, and you know, first of all, thanks Thomas, thanks Evelina for really extensive introduction. I hope that majority of it was relevant to our attendees, and seeing that we still have majority of them joined to this webinar. Please, the answer in my mind is yes. So let's get to some of the questions. Now, Joao was inquiring, is the PowerPoint going to be available for download? So even better, Joao, as always, we will upload this webinar to our YouTube channel. So you'll be able to reach it from our YouTube channel or from our website, where we keep all of the recordings as well. Next, one of the attendees was inquiring, for panic button, latency is crucial. Well, obviously. And what is the latency on TRB255? Now, since TRB255 combines both LTE Cat-M1 and NB-IoT, it would just make sense to use Cat-M1 in this case, because if my memory works correctly, it's about 10-15 milliseconds for the Cat-M1, which is similar to Cat-1, whereas NB-IoT has much bigger latency. It can range from 1.4 seconds to as much as 10 seconds. So although the device is compatible with both cellular technologies, from the operator side, you should go for LTE Cat-M1 in this case.
Yeah, I would like maybe to take part with the question I saw about the theoretical speeds, and of course, if our devices are able and how are able to achieve those speeds. First of all, maybe some part of why sometimes it's only theoretical speeds and it's not real life speeds. The part is that, as Ville mentioned, all those speeds really depend on external use cases, which most likely do not depend on the router. So for example, base station of operator load. So for example, you will receive better performance at midnight when the people are sleeping and not using their mobile devices. Of course, the state and of course the technology advancement of the base station itself. You might have the Cat12 device by itself, but if the base station and the tower near you only supports Cat6, you won't get over that, since again the base station providing the connectivity for you. So it always depends on what you need. But we have a great video in YouTube where we are showing how our devices can provide that speed advertised on the label. And we performed real live tests in Kaunas where we were using RootX11 and of course RootX12 with dual modems to show what we are able to achieve for communication speeds. And RootX11 with Cat6 were able to achieve 230 megabits per second download speeds. So again, those numbers are really comparable to real life. It only depends on how your ISP if your ISP can provide the speeds for you, and of course if you're having that luxury to get the space in the base station and the tower to get that performance. So again, to answer this, it's possible to achieve such performance in real life, in real cases, but also it depends on various factors outside, beyond sometimes your control.
Continuing on this topic, Tadas is inquiring, what are the real life download speeds for Cat4, Cat6 devices, Cat12, what's our experience? And like you said, Thomas, it's very difficult to establish, well, what is an ideal testing scenario, but not a synthetic one, not a laboratory environment one, but what is an ideal real life testing scenario? So let's probably not talk about the ideal testing scenario, but what we experience daily. Obviously, being here at Teltonika Networks office, we have plenty of devices around to play around most of the time. So I'll tell you my personal experience, what speeds I saw here at Warszawsko Street in Kaunas. So if we take probably our best-selling device, RE2240, which is based on Cat4, I've seen 80 plus megabits per second. If we take a Cat6 based device like X11, it's probably around 2 to 20. But then again, it depends on how congested the area is, what sort of time of day it is, etc. And in terms of Cat12, I haven't tried it out yet recently.
But one of our colleagues have tried at his home, Pranas with lte-a, and he mentioned that at the peak hours, like at the noon, at about 1 p.m., he was able to achieve stable 100 megabits per second. So, and he mentioned
considering that Pranas lives in
area
reception area, that's why he went for a Cat12.
Yeah, and that carrier aggregation possibilities and all the MIMO 4x4 antennas allow to push the limits of communication at his house. Since again, beforehand, if we're using just ISP provided router, he was only able to achieve 15 megabits per second. So again, that Cat12 router, enabled router, allowed to go like into proper internet speeds, instead of using device. And I'm really guessing that ISP was capping his performance at a base station, since again, ISP is not always are, into that to provide the best of the best performance to go on the edge, since again, they have to provide thousands and thousands of devices at the same time. So again, they have to allocate resources also significantly smarter. So, but
without going into too much depth, I would just say to Tadas, look, the general rule of thumb is that our products will, in good environment, in good conditions, will be able to reach about 70% of the theoretical throughput. And your mileage may vary, and it depends on all of the externalities that there is. Thomas, I would like to ask your help to quickly, easily explain the term MIMO. It's a question by our anonymous attendee.
Yeah, so MIMO is a simple multiple inputs, multiple outputs. At the beginning, it was at the dawn of the MIMO situation, it was really multiple outputs. So again, transmitting a signal and outputting signal have their individual antennas for additional space for signal to go through, and of course get best reception in this case. These days it's more for more signal control and the technology, but overall MIMO, it means still you have spatial streams for communication, and the more you have streams, the bigger possibility to have better connectivity. And the question which I also see about MIMO is that 2x2 or 4x4 MIMO really works. And my answer is yes. I had personal experience in my early days in Teltonika where clients which were not using secondary or tertiary antenna for the router was receiving worse performance. And after connecting those antennas, the performance goes up significantly. And for example, for our best sellers, Route 40, they adding additional antenna allow them to get performance from 20 megabits to 40, 50 megabits just by screwing in added antenna. So yes, MIMO really works and helps in communication situations.
I guess that answers Simas's question as well. Yeah. I wanted to take a question from Emil, and then we will focus on 3 questions by Alexander. Okay, so Emil is inquiring for the right model of TRB-245. He's saying, well, to have a list of countries in terms of which version of TRB-245 is the right one, for example, for India, Mexico, Taiwan, Vietnam, because we do not state countries in ordering information. Well, naturally, stating the countries in ordering information would, well, expand the section quite a lot. So we just focus on the regions and the bands of frequency. So I have 2 advices for Emil. So first one is to check this website, frequencycheck.com. And there you can choose a country, you can choose a carrier and see which bands are actually used in that specific country or scenario. Then you can compare that to the available version section of the device ordering information and discover, which version is the right for you. So that's a difficult way, although still quite easy. So for example, I chose Mexico, Movistar. I see that it utilizes B2 band for LTE, and I see that Latin America version of TRB-245 works well with that band. However, easier way is just to contact your Teltonika Networks sales manager, and they will take care of all the heavy lifting for you, Emil. So I hope that this helps for you moving forward. Now let's take a look at Alexander's questions, and I will just start from the beginning. Is there any indication that devices with Cat1, with a Cat M1 and NB-IoT fallback functionality might someday appear, saying that it would make those objectively better for non-battery powered industrial use cases? Do you have an idea, Thomas? or that's slightly out of the scope of your interests?
No, I think we can discuss, but of course, won't go too deep into this part, since it's not a secret that we are not manufacturing the modules of mobile parts. And at this point, our hands are a bit, cuffed what we can find in the market for those modules. And most of the time, if NB-IoT and Cat-M1, as mentioned in the webinar, is designed with idea for low power consumption and high and expanding battery life for mobile device. And maybe with some research, it's possible to find device which combines, Cat6 with Cat-M1 on NB-IoT. But at the moment, I really don't know. So, and at this point, we are getting into double modem device, which might be good solution for mission critical situations where you have to have that reliable last call connectivity. But at the moment, I cannot, promise any devices with such possibilities.
Good. Let's get into another question. Alexander is inquiring, does Teltonika recommend rather focusing on the right LTE technology instead of trying to improve performance through high gain antennas? What should customers do if connectivity or speed cannot be achieved at a certain location? My advice is always focused on efficiency in a way, on value, on the money and costs. So antenna accessories can get expensive for sure. Some basic antennas can cost 5, 10, 15 euros. A bit more advanced antennas can cost 20, 50, even more. We have some outside mounting external cases. We've seen some that cost upwards of 200 euros. So the range of the price of the antennas can be quite big. And if you take, let's say, a Cat4 device with standard antennas and doesn't really fulfill your use case, it doesn't offer as much speed. I'm slightly worried that trying out different antennas and investing in that, you could end up with a huge bill for different parts and accessories and still won't be satisfied. So when we talk internally about Cat6, Cat12 devices, we use this term that these higher category products can offer you twice or 3 or 4 times of bad throughput, right? If you are in a situation where the throughput is bad, the signal quality is poor, going up higher categories can multiply that amount of small throughput, and it can finally help you achieve the throughput that you're looking for. So my personal approach to this would be, if you have an environment in which, let's say, a Cat4 or Cat6 device is not offering what you need, I would first go up the category, because, at least in our portfolio, the price difference is not that radical. And then if you have the Cat12 device and you're seeing improvement but still not satisfied, then I would go deeper into choosing the right antennas.
Of course, maybe to add one thing on this part Marius mentioned, it always helps when antenna is outside, not inside the building. So at the beginning, when trying to see if things happens, and if device, at least our device can be brought outside to check if the performance gets better with just standard omnidirectional antennas we providing, it also can be a good test and indication if you have to go with outside antenna in this case. So I think these options, Marius route is perfectly good and to go. And of course, other part is investigate the situation in the area. Maybe it's not device problem. Maybe the area does not have certain coverage. And
There could be that the operator is not utilizing Cat12 and related carrier aggregation
Yes.
technologies in an area. So with so many different variables, I guess that the best thing is to consult us and test. So
Yeah.
we cannot be your feet on the ground and exact location, but we can be your brain remotely, having sold hundreds of thousands of these products. We gathered some experience, and we are very happy to talk not from theoretical standpoint, but from our experience. So we'll try to do our best to help. And wrapping up this webinar, I just wanted to say a huge thanks to everybody who joined us today. The recording will be shared with all of you, and you should check and subscribe to our YouTube channel, Teltonika Networks. There will be a recording in the upcoming days, and well, I guess we'll see you in the next webinars, different topics. So again, thanks, Thomas. Thanks, Evelina. If you have any advices, if you have any insights, drop us a message on social media, contact us through our website. We're always happy to engage. And yeah, best of Thursday for everybody.
Okay. Bye, everyone.
Have a nice day.
Have a nice day.